Welcome back, everyone. I'm Jordan Giesecke, and this is The Limiting Factor. Today we're going to be going through Tesla's Q1 2022 earnings call with a focus on batteries. This earnings call was primarily focused on the logistics challenges of scaling up the battery business over the next 5 to 10 years. Now, I've had concerns about logistics and material supply for the past couple of years, and that's really come into focus over the past few months. So I really enjoyed this earnings call, and it answered a lot of questions for me. Now, before we begin, a special thanks to my Patreon supporters and YouTube members. Those are the people who really make this channel possible. Although I am full-time now, I wouldn't call the channel necessarily financially resilient. So it is still a labor of love, and any support I can get, I appreciate, and the links for support are in the description. With that, let's kick into the earnings call, starting with the quarterly report slide deck. Starting with the section on battery and powertrain manufacturing. It states nearly half of Tesla vehicles produced in Q1 were equipped with a lithium iron phosphate LFP battery containing no nickel or cobalt. This is really impressive to me. Tesla's even further along with these LFP-based batteries than even I had suspected. I was assuming maybe 30%, maybe 40%, but half of the vehicles, that's really good. That allows them to stretch their lithium supply much further. It goes on to state, LFP batteries are used in most of our standard range vehicle products, as well as commercial energy storage applications. This was something I was suspecting. I was assuming that they were going to increase the amount of LFP batteries they use in energy storage products, and here that is confirmed. Now, it's worth noting this is commercial energy storage products, which is the power pack. This isn't the power wall. However, at some point, we can probably expect LFP batteries to be used in the power wall as well. And finally, it says Model 3 with an LFP battery pack can still achieve a 267-mile EPA range. And once again, this goes back to what I was saying in the LFP series that, yes, other manufacturers could use LFP batteries, but they simply won't get the range out of those battery packs that Tesla will. I'm thinking at most 240 to 250 miles out of an LFP battery pack, whereas Tesla, as they say here, 267 miles of range. And it's worth noting that 240 to 250 mile range that I'm stating here, that's probably generous to other manufacturers. I think when I looked at it, it was more like, 220 to 230 miles of range. But things are moving fast. Manufacturers are improving the efficiency of their powertrains. So even though they probably currently get 220 to 230 miles of range out of those packs, it won't be long before they hit about 250. However, by that point, how many miles of range will Tesla be getting out of these battery packs? Probably closer to 280, maybe even 300 in the next few years. It's worth noting that I'm referring to an equivalent battery pack here. Two manufacturers using the same battery pack, how much range can they get out of it? There are other manufacturers like BYD that are really cramming those battery cells under the vehicle, and they are able to get mid to high 200 mile range out of their battery packs. And they're probably able to squeeze even more in the future, but the focus here is efficiency. Next, Tesla goes on to confirm which battery cells and battery packs will be used in which vehicles in Austin and Berlin. They start off by saying, we delivered the first vehicles with 4680 in-house made cells, single-piece front body castings, and structural battery packs, which is what I confirmed in my Giga Austin video. They go on to say, later this year, we expect Gigafactory Texas will be able to produce Model Ys using both structural packs with 4680 cells, as well as non-structural packs with 2170 battery cells. I'll speak more about that in a moment. They continue, production at Gigafactory Berlin Brandenburg started in March 2022 using non-structural packs with 2170 cells for the start of production. Ultimately, Gigafactory Berlin Brandenburg will be able to produce Model Ys using both structural packs with 4680 cells as well as non-structural packs with 2170 cells. Now, everything Tesla is saying here aligns with what I was saying an entire year ago, that if they put a little bit of engineering into that 2170 battery pack, it should be able to fit into the same spot as the 4680 structural battery pack. That would require a little bit of tweaks to the body itself, but it would be a matter of just bolting the battery packs in and just changing which battery pack you're bolting in. Now, what do I mean by this? How can it be that a non-structural battery and a structural battery could occupy the same spot in a vehicle? Well, if that is what they're doing, let's take a look at one of the final slides in their deck to go through how that would work. And once again, this was covered off in high detail in my video a year ago on the structural battery pack. As we can see here, Tesla gives us two vehicle bodies, and this slide is a thing of beauty to me. It's I really enjoyed seeing this. It's everything summarized on one page. It gives you a good idea of what's happening at Giga Austin and Giga Berlin with one image. So on the left, you have a Model 3 body structure. That Model 3 body structure uses stampings in the front and rear, and you can also see at the base of the vehicle that there's a structural floor pan. On the right-hand side, you can see the new vehicle body that uses castings on the front and rear of the vehicle. And as you can see, there's no structural floor pan, and this is for the Model Y. And some people are wondering why the vehicle on the left and the vehicle on the right, the roof is slightly different. Well, that's because the Model Y uses 2 pieces of glass rather than the 3 pieces of glass that the Model 3 uses. So back to the Model 3 vehicle structure on the left. A typical Model 3 uses a structural floor pan. Now, below that structural floor pan is a 2170 battery pack. That battery pack, using 2170 battery cells, also has steel beams running through the core of that battery pack and around the perimeter of the battery pack. So the battery pack itself is actually a rigid structure. And what Sandy Munro has said in the past is, well, why don't they just remove that structural floor pan and make the 2170 battery pack integrate more completely with the vehicle structure? In that case, you would have a structural battery. Now, Tesla also has the structural battery that they referred to on Battery Day with the 4680 battery cells. What's the difference between the structural pack and the 2170 battery pack if they both provide structure to the vehicle? Well, the 4680 battery pack, rather than using steel beams to provide reinforcement to the battery pack, it glues all the battery cells together with 2 face sheets to provide one solid monolithic slab. Now, those steel I-beams that run through that 2170 battery pack, it's probably something like 10 pounds a foot of that I-beam. So if you're removing, say, 10, 15, 20 feet of steel I-beam from that 2170 battery pack, you're removing 100, 150, 200 pounds of steel from the battery pack. Now, some of that space will be filled in by epoxy foam, but that will be nowhere near as heavy as that steel I-beam. So once again, the vehicle on the left, it has a structural floor pan, and then typically would have the 2170 battery cells underneath. That would be redundant because the 2170 battery pack actually is rigid and could be used as structure, but it never was in the past. So the vehicle body on the right that we see here is actually 2 steps forward. Not only does it remove the structural floor pan and use the pack as the vehicle structure, the 4680 battery cells replace the steel beams within the pack, making that structural pack even lighter. I think what Tesla is doing with these 2170 battery packs is they're going, okay, well, we just make some tweaks to the 2170 battery pack and to the vehicle itself, and we can put that 2170 battery pack directly into the spot where the 4680 structural battery pack would be. Now, it's not going to be as light as that 4680 structural battery pack. However, it'll still serve a structural function and allow you to get rid of that structural floor pan that we see on the vehicle on the left. I can't guarantee that this is exactly what Tesla is doing, but it sure makes more sense to me to swap out these battery packs with just a few tweaks, rather than requiring an entirely different stamped steel vehicle structure, which I assume would also require an entirely separate vehicle line. So I'm interested in your thoughts in the comments below. If you can see any way of using 2 different battery packs within the same vehicle that's pragmatic and doesn't require an entirely new vehicle line. Let's get into the earnings call itself. In Elon's opening comments, he said, quote, We remain confident of a 50% growth in vehicle production in 2022 versus 2021. I think we actually have a reasonable shot at a 60% increase over the last year." End quote. Now, a few months ago, or a couple months ago at Giga Berlin, Elon said a 70 to 80% growth rate, and in my Battery News #1 video, I said he was probably referring to revenue because a 70 to 80% growth rate in vehicles, at this point, it doesn't seem attainable. And what he's saying here backs that up. And once again, as I said in the Battery News #1 video, if that is possible, it would most likely be possible this year or next year because they have so many new factories that are coming online, and on top of that, they have their 4680 battery cell line coming online. Next, Elon says, quote, "So we're also working on a new vehicle that I alluded to at the Giga Texas opening, which is a dedicated robotaxi that's highly optimized for autonomy, meaning it would not have steering wheel or pedals." End quote. First, obviously, this bodes well for Elon's confidence in full self-driving, and that's been covered off in other YouTube channels. What I'll say here is that at the last earnings call, Elon said that Tesla isn't working on a $25,000 vehicle. In my mind, the $25,000 vehicle and autonomous vehicle were one and the same. They were synonymous. Clearly, Elon sees this differently. It may mean, as I said in the last quarterly update video, that Tesla won't even bother to sell vehicles in the future because the best way to transition the world to sustainable energy is to make those vehicles robotaxis. Even if the vehicle would typically be sold for $25,000, if they don't sell it at all, it's not technically a $25,000 vehicle. But we'll see how that goes. Maybe they have something like a minibus planned for autonomy, but I have a feeling, based on Elon's comments in the past, that it'll be a smaller vehicle. Because in a post-pandemic world, people really value their own space. And he's comparing the robotaxi to public transport. It's going to be an alternative to public transport. And one of the benefits of having a robotaxi is you kind of have your own space, and you don't have to share that space with other people like you would with a minibus. And that's not to say they wouldn't also do that, but I'm thinking at least they would kick off with a compact taxi, compact robotaxi. And Elon goes on to say, quote, "And so I think it's going to be a very powerful product where we aspire to reach volume production of that in 2024. End quote. Now, it could just be dumb luck, but in past videos I've said several times that I expected it to be announced in 2023 and volume production in 2024. But as I said a moment ago, if it's a minibus, well then it turns out that I'm incorrect. But if it is that compact, subcompact vehicle that ends up being a robotaxi, then it looks like I was correct. But not that it matters terribly. It's to me, it was kind of obvious that with the amount of vehicles that Tesla had on their roadmap, that 2024 was the earliest that we're going to see a new vehicle in volume production. I hope to be wrong there. I hope maybe they come out with a new vehicle next year. But if there is, I would think it would just be a variation, like, for instance, on the Model 3, maybe a hatchback or something like that for Europe. Next, Elon says, quote, "We aspire to head to 20 million units a year. So we're basically 5% along the way towards our goal, and we're growing very, very rapidly year over year. And we remain confident of exceeding 50% annual growth rate for the foreseeable future, basically for the next several years." End quote. Of course, Elon is reiterating that he means a 50% growth rate target is for vehicles. And as I said, I think at Berlin, when he said 70 to 80%, I think he was referring to revenue. I'm looking forward to see if they can continue to hit 50% growth rate for the next 4 or 5 years. That would be phenomenal, given the material supply, which we'll talk more about later in the video. Finally, Elon says, "I've never been more optimistic or excited about Tesla's future than I am right now." Now, this is an important statement. It provides some reassurance, what he just said about the 50% growth rate. And it also, if there was any major issues with that 4680 cell ramp, which is part of the cornerstone of Tesla's strategy when we look into next year and the following years. If they had any doubts about that, I doubt he would be saying that he feels very confident, or more confident than he's ever been about Tesla's future. So that's it provides a bit of background to all the comments that will be made later in the video about 4680 production. The first question from investors was about full self-driving. And Elon says, in order to solve for full self-driving, we have to solve neural nets and cameras to a degree of capability that's on par with or really exceeds humans. Now, I wanted to target and focus on this because I don't know if people fully appreciate what's going on here. And maybe it's just that I'm ignorant and I'm letting my imagination get away with itself. But humans, or intelligent life on this planet, it first developed the ability to perceive and interpret what's going on in its environment. And after intelligent life developed that capability, then it developed abstract thinking on top of that. So you can probably see where I'm going with this. After we have the ability to perceive and interpret what's going on in the world, I think then we're going to start be building into artificial general intelligence, where you have an intelligence that's created. It could be 5, 10, 15 years from now, probably more like 15. But this sets us on the path, in my view, if we're following kind of an evolutionary biology pathway, it puts us on the path to developing an intelligence that's equal to our own, or perhaps several orders of magnitude more intelligent than humans. Once again, this is one of those things that I really got to get James Daum on here and pick his brain about this. Because for me, it seems like the way artificial intelligence will develop, it's going to have some similarities to the way that our own intelligence developed. The next question from investors was, how much raw material exposure do you have? So Elon says, our prices of vehicles ordered now are really anticipating supplier and logistics cost growth that we're aware of and believe will help happen over the next 6 to 12 months. Zachary Kirkhorn jumps in and says, we estimate we're around 10 to 15% of our cost structure exposed to raw materials. End quote. Now, usually raw material costs are about 40% of product costs. So I think what they're saying here is that 10 to 15% of their material costs are floating rather than fixed. If you have a better understanding of what they might be saying here, let me know in the comments below. Zachary Kirkhorn goes on to say, quote, in some cases, we have contracts with suppliers, but then as those contracts expire, we have to renegotiate them so there can be a lag. Now, some people have assumed that because Tesla has signed long-term contracts that they're golden and they're ready to go. Well, it depends on how long ago those long-term contracts were signed. It sounds like from the information that we're getting here that, those long-term contracts are going to start coming up. And so therefore, that argument doesn't really hold water. Even a long-term contract has to expire at some point, and those contracts are going to be expiring at a time when there's a much greater demand for raw materials. Now, luckily, Tesla has huge demand, so they're in a position where they can raise their prices, so the material cost isn't so much of an issue. The next question from investors was, why isn't Tesla using an 800-volt architecture in its vehicles? From my perspective, this is an excellent question because it's something I get asked quite a bit, and the answer that Tesla gave here aligns with my thinking on it and advice that I've given to people on Twitter in the past. Drew Baglino's response was, quote, for the smaller vehicle platforms like 3 and Y, there's some wins and some losses with 800 volts. Not everything is better, end quote. And then Elon follows up by saying, quote, let me just quantify that. Basically, our estimate is that going from 400 to 800 volts might save $100, but it's not really moving the needle, end quote. And then Drew backs Elon up by saying, quote, $100. It's roughly like a spreadsheet exercise. Like you have to get through the full program to the end to see that maybe it's been whittled away to $50 or less, end quote. So Elon is saying going from 400 volts to 800 volts might save $100. That's the maximum. And Drew is saying through the course of a vehicle program or implementing a project like that to increase the voltage, you may not see much of that $100 because the $100 is an idealized figure. It's on a spreadsheet somewhere, but manufacturing, you often run into complications when you implement something. So moving along, Drew says, quote, on bigger vehicles where you're talking about higher power on the charging side or higher power from the battery to the power electronics, or you need more torque so the current requirements go up, there's a little bit more semiconductor and actual conductor savings of going to the higher voltage. And so we do consider that for Semi and Cybertruck. But for the Model 3 and Y platform, where we've got everything running, the benefit is questionably small. End quote. So let's explore the logic a little bit here and what I've been telling people in the past about higher voltage architectures. For me, it was just, I didn't really understand the obsession, because if you go from 4 to 800 volts, well, that's just one side of the power equation. Power, which is watts, is volts times amps. So if you want more power, you don't necessarily have to increase the voltage, you can just increase the amps. Now, increasing the amps does generate more heat, but that's all dependent on how much power you're using and how much current you're running through those wires. So for a smaller vehicle, like the Robotaxi, it's pretty much no impact going to 800 volts. For a larger vehicle like the Cybertruck or Semi, which is taking enormous amount of amps through a 400 volt architecture, going up to 800 makes a lot of sense, because it's not going to generate as much heat with an 800 volt architecture. Now Model Y, Model 3, that's kind of right on the cusp. You can go 400 volts or 800 volts. The difference between those options is very slight. So I think what happened, the reason why they went with a 400 volt architecture on the Model 3 and the Model Y, it probably came down to something that was more critical to Tesla instead of saving $50 or $100, like the throughput of vehicles through the line, part availability, etc. It would have been some pragmatic reason why they went with the 400 volt architecture. Or it simply could have been a matter of pack design. The way that they had the cells laid out, it just, a 400 volt architecture might have evolved naturally from the way that they designed the packs. What all this amounts to is, when you're choosing a 400 volt architecture or an 800 volt architecture, you have to choose the right tool for the job. And there's a lot of different considerations that you have to, well, consider. So just picking the bigger number isn't always the best solution. You have to think about all the implications of any change you make to voltage in the vehicle. And so when people push for like an 800 volt architecture, I'm like, well, why? And there's never really a good reason besides it's more efficient. When you're building a vehicle, efficiency is just one thing you have to take into account when you look at the entire architecture of the vehicle, the architecture of the charging system, etc. It's part of a much larger ecosystem. Now, I'm still certainly no expert on voltage and battery management systems, etc., but maybe as a result of this video, I'll get some comments that maybe enlighten me or change my mind. The next question from investors was, how are the current 4680s performing versus expectations set during Battery Day in terms of expected range increase and dollars per kilowatt hour? Drew Baglino responds by saying, we're working in all the areas we shared on Battery Day, and we have to sort of consistently progress across all of those areas towards achieving the 5-year cost trajectory goals for the costs within our control. But we do not control all the commodity costs, so that's an exception I need to call out. End quote. As I said in my Battery News number 1 video, even with the 4680 line, we may not see huge decreases in battery cell prices because there's raw material price inflation happening at the same time that Tesla is driving down manufacturing costs. That's not to say there will be no decreases, but certainly not as drastic as we see in this image. But as I also said in that video, price is now a secondary concern. The main concern is now material supply and cell supply, regardless of cost. Now there are of course limits to that. They can't pay any price for battery materials. It's just to say that the landscape has shifted a bit, so they now have to factor in the actual supply of the raw materials going into the batteries, which it's not something that they've had to consider as much in the past. There were so many opportunities to reduce battery cell cost by improving the manufacturing process, and the battery raw materials prices were relatively flat. Drew goes on to say, quote, as we attain our manufacturing goals, we'll layer in new material technologies we are developing and higher range structural pack provisions, end quote. No surprises there. As I've said many times, Tesla will layer in chemistry innovations over time to de-risk their production ramp. This just serves as confirmation of my speculation. For example, I'd be surprised if the 4680 cells being produced today are both cobalt-free and have a high silicon anode. Both those are significant innovations, and they involve some risk. However, as Tesla gets comfortable with the battery cells they're producing and the manufacturing process, they'll inject more risk into it and produce battery cells that are higher energy density and more environmentally friendly. Elon then jumps in and contributes this little gem. Quote, I think it's probably fair to say that the 4680 in structural pack will be competitive with the best alternatives later this year, and we think will exceed the best alternatives next year. End quote. Now, the question was about range and cost, so this gives us a good idea of how Tesla is progressing. And the significance here is that later this year or early next year, Tesla will be producing the most advanced battery packs in the world that are also the cheapest, if he's referring to both range and cost there, which I think he is. Another way to put this more succinctly is that Elon and the team expect Tesla to have an absolute advantage in battery manufacturing versus any other competitor as of late this year or early next year, which is not too shabby for a new battery manufacturer. It's competing with companies that have been doing this for decades. Drew builds on that by saying, we've built the facility here in Texas. We know how much we spent on capital equipment in the facility, and it's more than 5 times less than prior technology installations. End quote. One of the more underrated aspects of Battery Day was Elon and Drew explained that they would be able to produce these battery cell manufacturing facilities at a fraction of the cost of other battery cell manufacturers. And this is essential for transitioning the world to sustainable energy. Scalability. Drew continues, quote, so we're saving huge on CapEx, on utilities and personnel. We know what those loads are and how many people are needed to run what is basically a highly automated factory. And we have massive reductions in both of those. End quote. As I've said in the past, it's what Tesla's doing at Battery Day and manufacturing in general is all about is driving the cost of the battery cell or whatever product it is you're making down to the cost of materials that go into it. And that's what Tesla's saying here. We're eliminating all the other expenses outside of the actual material that goes into the battery cell. Drew continues, quote, so like the cost model is well understood, it's really about rate and yield, which will come in time, as Elon said, over the course of this year and next, end quote. I'll talk more about rate and yield later in the video, but for now I just want to put a bow on what's being said here and that 5x reduction in CapEx cost. To me, this indicates that Tesla is using a dry battery electrode process because that requires so much less equipment. It considerably shrinks the size of the battery cell factory you need and the cost of equipment involved in creating battery cells. So I can't guarantee that this indicates that Tesla is using a dry battery electrode process, but it's a strong indicator. And I keep bringing up dry battery electrode in these videos because there's so much FUD around it. And if Tesla is able to lay down an electrode with a dry process, that's a big win. It's a big win for Tesla in terms of CapEx, production costs, and it's a win for the environment because it's a process that's much more clean than a wet process, which involves lots of toxic chemicals. Moving on. The next question from investors was, how does Tesla plan to secure raw materials required to scale to extreme size? Excellent question. Elon Musk responds, quote, certainly looking at say 5 million, 10 million, 20 million vehicles, you have to analyze the sort of macroeconomic, just like what the tonnage of the lithium is that you need, of nickel, of iron phosphate, of graphite separators, electrolytes. It looks like you really need to think like just macro tonnage, end quote. This is so good. This is exactly what I've been saying about the multiple material supply ramps that are needed to ramp battery cell production. It's not just one material that you have to be concerned about with the exponential curve. You have to look at all of them. And at some point, one of those materials is going to hold you up. The question is, which material is that? And how much is it going to hold you back? And how far can you look down the pipeline, down the trail, to see which material it is that's going to hold you up? Because it only takes one material to hold you up. Elon continues, quote, and when we need to think about this for the world as a whole, what are the limiting factors for accelerating the advent of a sustainable energy future? And whatever the most limiting factors are, Tesla will take action on those limiting factors. End quote. I just want to say here that it's reassuring to me that they're thinking at the right scale. My assumption was that these are the things that they're thinking about, but as I said in previous earnings calls, I felt like when these questions were asked in the past, they kind of lost an opportunity to reassure investors about where their mind is at. And this provides me with that reassurance. They're thinking at a global scale. It's such a massive problem. And as I've said before, this is going to require mountains of materials. Elon continued, quote, "So right now we think mining and refining lithium appears to be a limiting factor." End quote. Now, if you recall, in the last earnings call, Elon was asked a question about lithium, and he said, well, there's plenty of lithium in the ground. And in my recap video, I said, well, that's true. There is plenty of lithium in the ground, but the issue is mining and refining that. And here Elon is confirming what I said in my recap video. Elon continues, quote, "The actual content of lithium in a lithium-ion cell is maybe around 2 or 3% of the cell." Drew jumps in and says, 5 kgs a car. And then Elon continues, yes, exactly, 5 kg. It's called a lithium-ion cell, but by far, like the most expensive and heaviest item in the cell is the cathode. End quote. Now, from my perspective, people read way too much into these comments. There's a small but passionate group of people that were debating this on Twitter, and it seemed like there was two sides to the debate. One side of the debate was Elon and Drew don't know what they're talking about because these battery packs typically, what's quoted is usually about 11 to 12 kgs of lithium. Now, there's another group of people that said, oh, this might be hinting that there's some amazing new breakthrough that Elon and the team have made with lithium-ion battery cells. I don't think either of those are the case. It's just a matter of, first, if you increase the energy density of a battery cell, you're not actually reducing the amount of lithium that you use in the battery cell. When you increase energy density, all you're doing is stripping weight out of the battery cell that's not lithium. So that's how you achieve higher energy density. Strip out things that are dead weight, and that increases the concentration of energy within that battery cell. Now, with regards to the people who are saying, well, it should be 11 or 12 kilograms of lithium per battery pack. Well, that all depends on what battery pack they're looking at. If you choose a different battery pack size, that changes the amount of lithium that you're looking at in that battery pack. So a 100 kilowatt hour battery pack will have a different amount of lithium in it than a 50 kilowatt hour battery pack. Something like a small Robotaxi might only have like 5 kilograms of lithium in it. Now, there's also different calculations of how much lithium is required for a battery cell. There's the actual, and then there's theoretical in an ideal circumstance. All this boils down to, I think Drew and Elon know what they're talking about. It's just they either misspoke or they're looking at the amount of lithium required per vehicle from a different perspective. And I don't think there's any need to go any deeper than that, because unless we could actually sit down, Drew and Elon, and pick their brains and find out exactly what they're saying, the speculation is just kind of, well, it's pointless from my perspective. Elon continues, quote, "So we're looking carefully at all of the raw materials and trying to figure out how we can accelerate the total amount of raw materials needed to transition the world to sustainable energy. And I think we don't have enough time on this call to really go through all those details, but we are thinking about these things, and we think we'll have some exciting announcements in the next months to come." End quote. Now, if there's anything in the earnings call that's worth speculating over, it's this comment here. That's one hell of a tease, and I can't wait to see what Tesla has in store for us in terms of raw materials. Now, as I've said in the last video or two, I'm going to give my take on how I think Tesla is going to approach the raw materials problem. And that video hopefully should come out in the next couple of weeks. Drew follows up by saying, quote, "We're also committed to recycling at all of our cell factories. We're recycling 50 tons a week right now in Reno and ramping to 150 with all of that reclaimed material going directly back into our cathode supply chain." End quote. Now I found this to be an interesting comment because now in past videos I've covered off the fact that Redwood Materials has a facility just south of Giga, Nevada, where scrap material from Giga Nevada goes to be recycled. And then Redwood Materials, for its part, has confirmed that they're taking that raw material and sending it back to those producers. And clearly, Tesla is confirming that they're one of those producers that are reusing that recycled material. Now, what piques my curiosity is they're recycling 50 tons a week and they're ramping to 150. Now, I don't know how exactly that works because you don't want to ramp scrap material. So I don't know if what they're saying here is that they're taking a higher proportion of their material and recycling it, and maybe they're just, sending it off to a scrap heap or something before, or potentially another recycler, or if what they're saying is that they're taking batteries out of Tesla vehicles and sending them down to Redwood and taking the material out of vehicles, not just scrap material, and sending it down to Redwood for recycling. So that remains an open question for me. Hopefully they can clarify that at some point in the future. On one point of clarification on what I just said, when I say taking battery cells out of vehicles, I mean Tesla vehicles that are end of life, that have returned to Tesla and the battery cells are pretty much dead. That's significant because it shows that Tesla is starting to, if that's the case, it shows that they're starting to create a closed loop ecosystem to, put battery cells into vehicles, end of life, those battery cells come back, they send it off to recycle, take that raw material, put it back in battery cells. Drew continues on the recycling front. Quote, "We can take both scrap from the casting machines and the gating that comes out and put that into the aluminum melting pot. And then, as Elon was saying, also take any stampings and any other aluminum scrap and also throw that in the melting pot. As a matter of fact, we've also figured out that we can use wheels from practically any car." End quote. I really got a kick out of this because I can just see the engineers around the casting machine going, how about we take the aluminum rims off my car, throw it in there, and see if we can make a gigacasting out of it. And then the idea kind of grew, and they go, well, hey, we can just start raiding junkyards, etc., to get aluminum rims to feed our gigacasting process. So, but on a more serious note, there would be limits to this. I don't know if Tesla uses pre-mixed aluminum ingots that already have the minor alloying elements in there, or if they custom mix each batch and add in the correct amount of aluminum, the correct amount of silicon, etc. If it's the latter, they can throw as many aluminum rims as they want. If it's the former, then there would be a limit to the number of rims that you could throw in and still maintain the characteristics they need for those gigacastings. The next question from shareholders was, quote, "At what rate do you expect Berlin and Austin to ramp relative to Shanghai?" End quote. Elon responds, quote, "Ramp production faster than Shanghai because we've learned a lot. We basically have veteran teams that were involved in the Model 3 and Model Y, the Y ramp especially in multiple locations. And we're obviously sharing what we've learned. And we have done a lot to simplify the production processes of the Model Y that should lead us to ramp faster within Texas and Berlin." End quote. Now, in my Giga Austin video, I said that I wasn't concerned about the speed of the 4680 cell production ramp at Austin because I thought those batteries, the vehicle lines, might ramp more slowly than the cell production lines. And what Elon is saying here is obviously running counter to what I'm saying. Now, what I would say here is, so even if Tesla is able to ramp those vehicle production lines at Austin operationally and technically quicker than Shanghai, my secondary concern would be the amount of chips that they've had, because Elon continues to say that chips are a bottleneck. If Tesla has all the chips that they need and all the battery cells they need with the 4680 and 2170, then we should see an extremely rapid ramp at Giga Texas. Will that be the case? We'll see. There's a phrase that Drew and Elon have been using that I'm growing fond of really quickly, which is they refer to the least lucky step or material needed for a production ramp. And, in this situation, you have the cells, you have the chips, and then you have the vehicle production ramp itself. And it could vary over time from week to week or month to month as to which one of those things is actually slowing the production ramp at Giga Austin. Drew follows up by reinforcing what Elon said with this comment, quote, "But we also had a structural casting, about 30% less robots. We expect to almost double the capacity for body, for example, reducing the number of robots, but doubling our capacity in a lot of areas." End quote. So what Drew is of course saying here is that he has confidence in the ramp in Austin because the factory itself is much more streamlined than past factories, and it also has a much greater capacity than previous factories. Now, at this point, Lars jumps into the call. Now, generally, Lars is in the background, he's kind of quiet, but when he does jump in to provide insights, it's usually pretty interesting stuff. So he says, quote, "We have a structural battery. The floor is the battery. We put the seats on the battery, and we put that in the car. So there's 10 to 15% less stations in general assembly, end quote. In my Giga Austin video, I said it was a big deal for them to mount those seats directly onto the battery pack and then to lift that battery pack and seat assembly up into the vehicle. And Lars is confirming that here. In fact, it has an even bigger impact than I expected. 10 to 15% less stations in general assembly due to that structural battery pack is quite significant. Lars follows up that comment with this gem, quote, "So really, like I think about this and the way we think about cars, if you're waiting for the best Tesla, you're going to be waiting forever," end quote. Amen. There's a small group of people out there who obsess about the version of the technology that's in their Tesla vehicles. But for most people, that's not something you really need to be concerned about because Tesla wouldn't provide a significantly different customer experience between a Tesla with a 2170 cell and a 4680 cell. There will be some slight differences, but I don't know if those differences would be much different than what we're seeing on a month-to-month basis from Tesla, because every week Tesla's making improvements to their vehicles. And if you want to know more about that, I recommend watching the videos by Joe Justice. He worked in Agile at Tesla, and he gives some great insights into exactly how fast Tesla is innovating on their vehicles and how quickly they're improving them. I'd like to build on what Lars is saying there because the people who specifically waited to get a Tesla in the past year, waiting for newer technology, put themselves at a significant disadvantage in terms of value for money for those vehicles, because the price of Tesla vehicles has increased significantly over the past year, and we don't know if that's going to continue. Will the price of Teslas keep appreciating? I'm not sure. It depends on if inflation keeps rising, or if Tesla releases their full self-driving and all these vehicles now have the ability to make you money. So I can't predict the future, but it certainly, for me, reinforces the idea that it's not worth waiting for the new technology and to buy sooner rather than later. One thing that's worth stopping to appreciate here, besides the technical information that they're giving, is the dynamics between the people on the earnings call. People are jumping in and contributing to what other people are saying. It feels very cohesive. It feels like they're all pulling the same direction and they're all on the same wavelength. And that's just as important as the technical information that they give. It's reading between the lines and looking at the context and looking at how these people work together. And I get a really good vibe, especially the past few earnings calls, as to what's going on between the people there. It feels like it's getting to a point where Elon might be able to start stepping away. And I know he's tried to in past earnings calls, but it would be great if Elon could free up a bit of his own time to focus on the things that he's really interested in. And God knows he has enough on his plate already anyways. So hopefully this will continue over the next few years, and we'll see people within Tesla step up to the plate and allow Elon just to step back a bit and take more of a balcony view rather than being on the dance floor in the chaos. The last question from investors was, quote, "What is the current run rate of 4680 cell production at Fremont and at Giga Texas? What do you expect run rates of 4680 to be in Fremont and Giga Texas or Berlin at the end of the year?" End quote. Elon responds, quote, "Berlin is using the 2170 non-structural pack, so they're not constrained by the 4680. They will transition to 4680 hopefully later this year, but current building production does not require that. We also have, just as a risk mitigation, 2170 non-structural pack capability here at Texas as well. But if things go according to plan, we will be in volume production with 4680 sometime perhaps towards the end of the quarter and certainly in the fourth quarter." End quote. As I've said in past videos, Tesla isn't going to risk their production ramps at Berlin and Austin due to a battery cell shortage. What they're going to do is they're going to have fallback plans, and that's exactly what Elon is saying here. They're using a combination of the 2170 and 4680. Now, after they finish that ramp in the third and fourth quarter, if they get to that ramp in the third and the fourth quarter, that means we're golden for the next year. We're good for 2023 in terms of cell production. Now, if they start running into issues later this year, well, that would be a concern with the 4680 cell. But as I said earlier in the video, Elon's general confidence in the way things are going, and some comments that Drew's going to make here in a moment, give me a lot of confidence that things are just humming along well with the 4680 ramp. It's probably not as far as they'd like to be based on past information, but it's not holding anything up, and they're comfortable with it the way it's progressing. Drew jumps in and says, quote, "And the other thing I would like to add is like with the China COVID shutdown and the semiconductor bottlenecks we had through Q4 and a little bit in Q1, we have a sizable cell inventory at the moment and excess cells to support the 2022 volume targets you described." This was such a useful and valuable comment from Drew. Not only do they have plenty of cell supply, they actually have a glut at the moment. They have battery packs and cells sitting there waiting to go in the vehicle. So once again, it takes a lot of pressure off the 4680 production ramp. And on that theme, Drew continues, quote, "So that gives us the ability to be pretty deliberate in the 4680 ramp, where we can maximize learning step by step, take engineering downtime to upgrade key pieces of equipment, and modify the structural pack design to improve reliability." End quote. For me, this was one of the most underappreciated comments in the earnings call. There's a lot of people who have been critical of the speed that the 4680 cell production ramp has been going at. And as I've said, well, first off, there's no necessity for that 4680 ramp to be going faster. The only necessity is that they hit the scale they need to by the end of this year and into next year. But Drew is providing even more reason why we shouldn't be concerned about the speed that the 4680 ramp is currently ramping. What Drew is saying here is that there's kind of a silver lining to the situation that they currently find themselves in. They have a glut of 2170 cells. They have plenty of battery cells to meet their production needs this year. What that allows them to do is, as you're ramping a production line, there's things that you come across and you go, all right, that's something we need to improve in the future. That's part of the process that we'll have to come back to and streamline or improve the capacity of in the future. And they're doing that now as the battery cell line is ramping. It's exactly what he said. They're able to be more deliberate. They just don't have to push through this production ramp for the 4680 battery cells. They can improve the lines as they're moving along instead of deferring that to some point in the future. Elon follows up on that by saying, quote, "Yes, 4680 output is not a risk to achieving 1.5 million vehicles produced this year, but it would become a risk next year if we don't solve the volume production problem by early 2023. But we're highly confident of doing so." End quote. Once again, this comment by Elon wraps up everything I've been saying in the video. They have the cells they need. The 4680 ramp is going well, and overall, he has general confidence in what they're doing. And these things shouldn't become a concern for us and won't become a concern for Tesla until they get into later this year. Because those 4680 production lines will be needed next year if they want to continue to ramp at 50% per year. The only exception to that would be is if Tesla is able to find even more battery suppliers to provide the battery cells they need to support their ramp. And I don't know if the cell capacity is actually out there to be able to do that. So I suppose if that does happen, well, we'll cross that bridge when we come to it. It's also worth noting that just a moment ago, Drew said that they expect to hit volume production with the 4680 in the third quarter of this year, and certainly by the fourth quarter. And what Elon is saying is they just need that by the first quarter or early in 2023. So that provides me with a bit more assurance that there's a little bit of a buffer there, potentially of about 3 to 6 months for Tesla for the 4680 volume production ramp. Let's move on to the analyst questions. The first question was, I'm trying to parse out your comments about the inflation and constrained supply and battery feedstocks, and the initiatives that you're working on internally to secure these materials. It sounds like you're optimistic about Tesla's ability to solve this for Tesla, but do you see this as a constraint on EV adoption more broadly? End quote. I can see what the analyst was driving at in this question because there's two parts to it. First, it looks like Tesla has the raw material supply they need, so that wasn't necessarily a question. The second part of it, the actual question is, do you see this as a constraint on EV adoption more broadly? And Elon and the team completely avoided that part of the question. And I don't know whether that was on purpose, but by avoiding that, they certainly avoided some landmines in the discussion. Because what I've been saying for a while now is that if Tesla, if they have the deepest pockets, and if they can secure these raw materials, and they've been working on this problem the longest, is there going to be enough materials left for other battery cell manufacturers, i.e., enough battery cells for other automotive OEMs to electrify their fleets? And from what I can see, it's going to be really tough for other auto OEMs to electrify their fleets because they just haven't done the work to develop their raw material supply chain and their cell supply. Now, that doesn't mean that legacy OEMs won't have access to any cell supply or any raw materials. They will. It just, from my perspective, it won't be to the same scale that Tesla is able to access raw materials and battery cells. And I'll cover that, the reasons for that a little bit more in the video that I do on Tesla's strategy for securing raw materials. However, I think the key question is, and what I think the analyst was getting to here is, if these legacy auto OEMs are restricted in the amount of battery cells and raw materials that they have access to, will that be enough to keep them in business? Because their internal combustion fleet, that'll be waning. And in the meantime, they have to ramp EVs fast enough to keep their companies from going bankrupt. Have they secured enough battery cells to do that? I don't have the answer to that, but I would be concerned if I was a legacy OEM. But let's get to Elon's response. And once again, he avoided the second part and he was focused on Tesla's ability to secure raw materials. And his response was, quote, "Yes, absolutely. It's the fundamental limiting factor is the output of cell, basically cell output. At what rate can lithium-ion cells increase the gigawatt hours per year? And that will move as fast as the slowest, least lucky element of the whole supply chain. Currently, we see that as being a challenge with lithium," end quote. Now, we've pretty much already covered off what Elon's saying here earlier in the earnings call, but just a quick recap, Tesla is growing at greater than 50% per year. All the elements in the raw material supply chain are growing at slower than 50% per year. So at some point, that's going to hit a bottleneck, that's going to hit a head. Right now, Tesla is going to do the best job they can at predicting what that iceberg is hiding out there in the ocean of raw materials. And right now, they think that iceberg is lithium. However, it might be more appropriate to think of this as an ongoing challenge that Tesla is going to face. It's not just one iceberg out there that they have to avoid with raw materials. It's a whole flow of icebergs, and Tesla is going to be constantly navigating around these raw materials issues for the next 5 to 10 years, probably even beyond that. Elon continues, "Lithium is present almost everywhere. It's a very common element. However, you still need to take up the ore, take up basically sludge or whatever, the clay with the lithium, and then you need to go through a whole series of refinement steps. And there's a lot of industrial equipment that's needed to refine lithium ore to lithium that can be used as lithium hydroxide or lithium carbonate in a battery cell. So we think we're going to need to help the industry on this front," end quote. This is one hell of a tease. And this is another thing in the earnings call that I'm surprised people haven't focused on, because as we saw the other day, Elon's looking at signing agreements with Indonesia to potentially build a cell factory there. Now, in the past, I've said that Indonesian nickel is dirty, and if possible, Tesla will avoid it. Well, there's another option. Tesla can work with these Indonesian manufacturers to make their process cleaner and safer. So that way Tesla can avoid public relation risks and public relations nightmares. So in my head, I see Tesla's engineers going out into the mining industry and helping them upgrade their processes to make them safer and also make them more environmentally friendly. So I hope that's what we see, and I hope this is one of the things that Tesla is going to reveal in the next few months. Elon continues, quote, "I think we're seeing cases where the spot lithium price is 10 times higher than the cost of extraction. So we're like talking 90% margins here. Can more people please get into the lithium business? It's like, do you like minting money? Well, the lithium business is for you," end quote. Now, personally, what I think Elon is trying to do here is As much as possible, I think Tesla is going to avoid getting into mining. They're only going to get into mining unless they absolutely have to. As I was saying earlier, there's public relations risks when you get into mining, and it's a completely different business model than Tesla is used to. So what Tesla can do is they can take a multi-pronged strategy to get the raw materials they need. And one thing they can do is encourage and push as many people as possible to get into mining. And I think that's what Elon's doing here. If we can get more people in the mining, it means Tesla has to do less themselves. And instead they can use those engineers to scale their vehicle manufacturing and battery cell manufacturing. So yeah, for me, what Elon's saying here is much deeper than surface level. He wants to try to get people into lithium mining so Tesla can avoid it. And so Drew jumps in and he says, quote, "Our mission is to accelerate the transition to sustainable energy. So we're working with our existing suppliers and others to figure out how to grow all of these raw materials as quickly as possible to not slow down the transition. And whether that means we have to get directly involved in some cases or not comes down to the counterparty and their willingness to expand at the rate we think they should expand at." End quote. This reinforces what I was just saying and my own theory about what Tesla is doing. Here, Drew has basically said, we'll get involved if we have to, but as much as possible, we're looking at the people who own these mines and their ability to expand and what rate we think they can expand at, which is, it also illustrates an extremely high level of maturity in Tesla's analysis of their supply chain. They can look into other people's mines and determine if they can expand that mine and how quickly they can expand that mine. As far as I know, other legacy OEMs at this point, they're only looking at if they can secure the cells, let alone the material supply chain to make those cells, let alone looking at each individual mine and being able to determine at what rate they can expand. And notice that I'm saying legacy auto OEMs here, because besides Tesla, I think the other exception here is Chinese auto manufacturers like BYD, who also manufacture their battery cells in-house. Drew closes the conversation off by saying, quote, "And so, we will do what needs to be done to not slow down the transition. And affordability is a goal because if it's unaffordable, it's going to retard the growth of what is inherently a good thing, that we can't have that as an outcome." End quote. I love the determination here. It seems like there's a lot of passion there to tackle this problem, and that's what's required. And also notice here that he's basically linking the affordability and materials availability challenge together. So as I was saying earlier, it's all about getting those raw materials, and pricing is a secondary concern. What Drew's saying here is a variation on that. He's saying, well, if we don't expand our raw material supply because there's not enough raw materials, prices will become unaffordable. So in order to drive down the cost of those materials have to become more available, and Tesla's going to get involved to make that happen. Finally, the discussion moves on a bit from raw materials and battery cells with this question from an analyst. Quote, "How would Cybertruck compare with the traditional pickup truck in terms of number of parts?" The second question I have is on Gigafactory Nevada, Sparks. Will we have any production of vehicles in that factory, or all the future production will happen in Giga Austin? End quote. Lars Moravi responds to the Cybertruck question with this, quote, "So with the Cybertruck and the doors, for example, we have an exoskeleton design where the door is ready to take and takes all the impact. So we really have, we don't have the door reinforcements." End quote. If you want to know more about what Lars is saying here, I made an entire video on how I think the Cybertruck will be constructed, and I devoted an entire section of that video to the doors themselves. In short, basically, most car doors are a sandwich of layers, and in between those layers there's reinforcements to help with vehicle impacts. Now with the Cybertruck door, it's just the inner shell and the outer shell, and there's not a whole lot of material needed in between. So it greatly simplifies the number of layers in those doors and simplifies the manufacturing process. And it should weigh about the same as a typical steel door because the overall thickness of the steel will be the same. It's just compressed into 2 layers rather than multiple layers. Lars continues, quote, "So to your point, I haven't counted them because I don't often look back at old technologies to decide how well I'm doing. I check that once in a while, but in general, architecture is always moving to reduce complexity, reduce parts, or reduce parts counts. I would say, ignoring the battery cells, we are probably 20 to 30% less. End quote. I really like the subtle shade that Lars is throwing at old technologies, like ICE vehicles and legacy auto manufacturers. With that said, I think Lars might be being conservative here. My understanding is a typical internal combustion vehicle has about twice as many parts in it as a typical electric vehicle. So I'm not sure if he's just referring to the body-on-frame design versus the exoskeleton design. I'm looking forward to Sandy Monroe doing a teardown of one of these Cybertrucks so we can get more granularity on that. But of course, that's probably going to be 18 months to 2 years, I imagine, before Sandy Monroe gets his hands on one of these. Elon then responds to the question about expansion at Giga Nevada. He responds, quote, "Do we expect to expand? Yes, we do expect to expand at Giga Nevada. There's a lot of room for expansion there, and we do expect to increase output from Nevada, but by far the biggest increase in output will be from Giga Texas." End quote. What that question was asking more specifically was, does Tesla plan on building vehicles at Giga Nevada? And I don't think that's the question that Elon was answering. I think Elon was just looking at it from a broader production perspective for battery cells. Will Tesla be increasing the output at Giga Nevada? And as they've said in the past, they still plan to increase output at Giga Nevada with Panasonic. So in order to understand the answer to the question, well, is Tesla going to be building vehicles at Giga Nevada? I think that question would need to be asked again. Now, my personal view is, no, I don't think they're going to be building vehicles out there. My understanding is they've had just getting enough staff for the battery cell production side of things with Panasonic. That's been quite an issue. So as you've noticed, Tesla has built all their factories in more urban locations where they have a deep pool of engineers and talent to pull from. The next analyst question was, quote, "How quickly can raw material supply be built? Because my understanding is that it takes many years to build that out. And related, how quickly can you switch to like LFP for the nickel issue?" End quote. Well, the second part of this question I found frustrating because that was already answered in the slide deck. And if you're paying attention over the past couple of years, Tesla has gone from being 100% nickel cell supply for their vehicles to around 50% already. And that was just over the course of about 18 months. So that question answers itself. But Drew does add to that with this comment, quote, "And there's more to be done on the cathode side, and we're actively pursuing it to give us substitution flexibility in response to market conditions between the other cathodes that are out there that can be competitive in our vehicles, which there are many options." That's an interesting comment from Drew. There's so many different cathode options that are available. My best guess is that he's referring to lithium iron manganese phosphate or a lithium nickel manganese oxide, or potentially maybe he's even referring to a sodium ion battery. But there's not enough information there for us to really speculate. So we'll just have to wait and see. This is another one of those teases that were dropped into the earnings call that I'm looking forward to hearing more about. Drew continues, quote, "Not all of the materials that go into cathodes are actually, first of all, hard to secure like through mining or refining, and second of all, in many cases, are like very plentiful already, like huge scale. And if all of the batteries in the world use those cathodes, it's less than a 1% increase in total annual output." End quote. My perspective on this, and this is something I'm still researching, is that I'm assuming he's referring to iron here, because iron, there's a huge quantity that's available out there. But I view it similar to Elon's comment from a few months ago about lithium, where he said, well, there's plenty of lithium out there, and he didn't dig that level deeper. With iron, most of the iron that's currently produced is for structural applications. Well, battery-grade iron for lithium iron phosphate batteries is a different beast. It's a specialty chemical, and it typically comes from very specific mining and refining processes. So there is an enormous amount of iron available out there, but getting the right type of iron that goes into batteries, that will take a bit of investment and work. But with that said, that's nitpicking on my part, and I think until I hear otherwise, I'm not concerned about the iron itself, but it is something I'm looking into. And not just the iron, but the phosphate required as well. In fact, that's actually more of a concern for me from what I've heard with the shallow dives I've done looking into it. Drew continues, quote, Elon already spent a lot of time talking about lithium. It really depends on the resource. Some resources, like just getting rocks out of the ground, expanding the amount of rock that you're getting out of the ground, is maybe a little bit of paperwork and some additional sort of blasting and trucking operations. End quote. Now, it's worth noting here that Drew was careful with his words in this sentence. He said some resources, and he's referring to getting rocks out of the ground. It sounds like what he's referring to is spodumene deposits in Australia, where there's already large mines and large mining companies there, and they might have the ability to just do some paperwork and expand on an existing mine. But you can't take that assumption and then apply it to the rest of the lithium mines in the world and the rest of the lithium resources. Most of those resources are going to take quite a bit more paperwork to get them online. Drew continues, quote, the refining is maybe where there's a little bit more chunky to bring it online, but also the refining it's not like an oil refinery. It's much smaller operation to refine lithium out of spodumene or for liquid, like brine or a salt pond evaporation, end quote. In this sentence, Drew's subtly shifted gears. In the last sentence, he was talking about permitting. And he was saying it takes maybe 1 to 2 years for some of these very specific deposits to bring more mining online. And that's technically not difficult. Now, he's moved on to talking about the refining process, which is much more technically difficult. Now, I don't know about the permitting process required for that, but I imagine the permitting process for a refinery is much less than mining because you're not digging into the ground as much. Again, this is something where I still need to learn quite a bit about it, but in the past, when I've been following mines, it's typically the mine itself that causes the permitting issues. So we're talking about two separate issues here. Mining, and then the technical aspects of actually upgrading that mined material into something useful. And of course, what he's saying about it's not as complicated as like making an oil refinery. That's correct, but it still will require manpower and resources. And I think that's an area where he might be hinting to Tesla can jump in and provide a bit of expertise. Drew continues, quote, so you're talking about a timescale of 1 to 2 years, and it's not like we haven't been talking to all of the lithium suppliers out there for many years. They have a lot of projects already in the pipeline to come online this year and the next, end quote. Again, a timescale of 1 to 2 years, he might just be referring to low-hanging fruit and material supply, lithium supply that they expect to come online in the next couple of years. However, beyond 2 years, things might get a bit more tricky. You can't continue to import all the lithium you need and move it around the world, which is one of the focuses that Tesla had at Battery Day, moving those lithium molecules around the world or moving them across the country or across the state is a lot easier. So how are things going to look in 3 to 4 years? I don't know, but it does give me confidence that Tesla has the materials they need for the next year or two, which I've been saying the past few videos. It's 3 or 4 years in the future where things get a bit more hairy. Drew continues, quote, some of what's going on in the lithium market this year doesn't actually have truth to bear to like the fundamentals of supply and demand, which is also a little frustrating. But yes, if we look at past this year or next year into 2030, when we need 15 to 20 terawatt hours of this stuff to get on the growth trajectory, stay on the growth trajectory we're on, we need everybody to do more in the lithium space than there currently are, end quote. Now, what he's talking about in the lithium market with supply and demand, I'm not in any position to speak about that. What I do know is lithium prices are ridiculous this year, and if Tesla wants to do something about those high lithium prices and become the masters of their own destiny, they're going to have to dig deeper into the mining. I don't necessarily know if that means them getting into mining themselves, but there are strategies that they can put into play to gain greater control of lithium while not necessarily mining lithium themselves. Drew's last comments are the most telling for me. As I said a moment ago, it sounds like the next 1 to 2 years they're in a good position, but he says here we need everybody to do more in the lithium space than they currently are. He's talking about 2030 when they need 15 to 20 terawatt hours of this stuff. And that all indicates to me that deeper into the future, there isn't so much certainty, and we need everybody that can possibly do lithium mining to get into lithium mining, because as I keep saying and pounding the table on, we literally need mountains of this material and mountains of all the other materials as well. So if Tesla signs an agreement for something like 100,000 tons, that's a drop in the bucket compared to what they will need. Finally, there's a question about Tesla insurance, and this really isn't my ball game here, but I will add some thoughts on it because I have signed up for Tesla insurance. It's absolutely excellent. Like I checked the potential insurance rates to insure my long-range Model 3, and it was something like $1,500 a year. And with Tesla insurance, it's more like $300 to $400 a year. So for me, it's one more reason to buy a Tesla. Not only am I saving money on gasoline by using electricity, I'm also saving a huge amount of money by using Tesla insurance. And those two things alone are enough to, pay for the car in, say, 15 years compared to getting an internal combustion vehicle. All right, that was one heck of an earnings call. There was so much useful information in there for me. It answered a lot of questions that I've been curious about for a while. A lot of the information that, I would have liked to have more detail on isn't really necessary at this point. As I've said in previous earnings calls, there's a few key questions that I needed answering, or I wanted to have answered just for my own security as an investor. And those questions were answered today. I can keep digging, a mile deeper, but I got my key questions addressed in this earnings call. Let's do a quick summary of the 15 key points related to batteries. I've divided these up into 3 slides of 5 key points. First, 50% of Tesla's vehicles now use LFP. That means for a given number of vehicles, Tesla's using half the nickel. And as we know, nickel is one of the key bottlenecks for battery electric vehicles. 2. 2170 and 4680 battery packs may be interchangeable. That is, Tesla is prepared to use multiple form factors and chemistries to make sure that they can use any battery cell to continue ramping their vehicle lines. 3. The Semi and Cybertruck may use an 800-volt architecture. The reason why an 800-volt architecture makes more sense for the Semi and Cybertruck is because those vehicles are so large that at a 400-volt architecture, it'd be pulling so many amps that it would generate heat and inefficiency. Now, it becomes even more important for those vehicles because those vehicles are also large. The larger that you make a vehicle, the harder it is to make that vehicle more efficient. So any efficiency you can squeeze out of that, the better. Tesla confirmed that an 800-volt architecture just doesn't make sense and it's not persuasive for the Model 3 and the Model Y, because at most it would save about $100 per vehicle, and it's pointless for the Robotaxi. Now, in the video I said that Tesla has a few different options when it comes to that Robotaxi, but now that I've reviewed the earnings call again and noticed Tesla's point about the Robotaxi using a 400-volt architecture, that indicates to me that it's most likely not a minibus, and it's more likely a compact or a subcompact vehicle. 4. The 4680 battery cell is on track to meet cost targets. Overall, the 4680 battery cells and pack will achieve an absolute advantage over any competition later this year and early next year. 5. Tesla has achieved a 5x capital cost reduction. That's past tense. This is something they've already achieved. It also hints that a dry battery electrode is being used. A wet process tends to involve quite a bit more capital because you have to have drying lines that are hundreds of meters long. Moving along to the second set of 5 key points. First, lithium is Tesla's limiting factor for superscaling. That doesn't mean they won't run into other raw materials issues, but the primary thing they're targeting is lithium. And Tesla said there's going to be some exciting announcements coming in the next few months on that topic. Hopefully, that means we're going to see raw materials and mining as part of Tesla's Master Plan Part 3. Another thing that I was thinking while I was putting this together was, what else does Tesla need for extreme scaling besides raw materials? And I think chips would be something that would benefit Tesla to bring in-house. I don't know if that's feasible or not. I think it's pretty far-fetched, but given all the issues that Tesla's run into with chips for the last few years, it is possible. As Elon has said, and as Drew said on this earnings call, they'll do whatever it takes to continue scaling to transition the world to sustainable energy. Second, Tesla's ramping up their battery recycling efforts. As I said in the video, I don't know exactly what this means. Maybe this just means that Tesla is increasing the proportion of material that they're recycling. Regardless, this is a great opportunity because typically, 10 to 15% of the battery cells that are being produced at Giga Nevada are lost due to yield, and those battery cells need scrapped. So that's 10 to 15% of the lithium supply that would be lost due to the yield. If Tesla can get that back, that's fantastic. That's 10% more battery cells. 3. The Gigafactories at Austin and Berlin are expected to ramp quickly. That runs counter to my assumptions, which was that the vehicle line would have been ramping at about the same speed or maybe slightly slower than the 4680 ramp. However, it looks like Tesla expects those vehicle lines to ramp quicker, so they have 2170 battery cells and packs on standby just in case. 4. The 4680 is expected to hit volume production in the third or the fourth quarter. If that ramps quickly enough, then Tesla won't need to use the 2170 battery packs at Giga Austin. Regardless, Drew and Elon emphasized that the 4680 ramp is no threat to the 1.5 million vehicles expected to be produced in 2022. They advised that Tesla actually has excess 2170 cells, which can of course be made into packs that go into vehicles. They're taking advantage of that safety buffer to upgrade the 4680 lines and pack design. So overall, even though the 4680 lines are ramping rather slowly, it appears that that's not affecting Tesla's ability to produce vehicles. However, if we get to the third quarter or later at the end of this year, and Tesla's still not able to ramp that 4680 line or those 4680 lines as quickly as they'd like, then it'll start becoming concerning, because Elon advised that in early 2023, some of their vehicle ramps, it sounds like they're contingent upon those 4680 battery cells. And to clarify there, that doesn't mean that those vehicle ramps wouldn't occur at all. It would just mean that those vehicle ramps would occur more slowly than expected and hamper Tesla's ability to grow in 2023. But once again, there may be other levers that they can pull to get the battery cells that they need. So, as I said earlier, we'll cross that bridge when we come to it. Next, the third set of 5 key takeaways. First, Tesla views the refinement of lithium as a bottleneck. Now, what they also said here that was quite interesting is they may help the industry out. I don't know what that means, but to me, it sounds like lending engineers and lending process information. Tesla's been doing quite a bit of work on extracting lithium and other chemicals from larger bulk materials. And they've been doing that for quite a few years now. If you'd like to know more about that, you can see my previous videos on Tesla's lithium clay. Number 2, Tesla is pressuring suppliers and analyzing their operations. They're trying to squeeze as much material out of those mines as they possibly can. This is so Tesla themselves doesn't have to get into mining, and if they do have to get into mining, it means that Tesla will have to do less work in the mining space. And Tesla, they've hinted to the fact that they're going to be providing support to these miners. We don't know what form that support will take. But as I said a few times, I'll give my thoughts and perspective in an upcoming video. Number 3, on Battery Day, Tesla said 100 gigawatt hours in 2022, and they didn't specify whether that was total production, run rate, or installed capacity. So how's that going? Last I recall, they had ordered 100 gigawatt hours of equipment for both Austin and Berlin. We do know that they've installed the equipment at Austin. We don't know if that's 100 gigawatt hours or not, but let's assume it is. Drew and Elon have said that they expect to hit volume production there by the end of the year. However, they didn't specify what volume production means. As for Berlin, it was supposed to get 100 gigawatt hours of production equipment last year. However, after Austin was prioritized for cell production over Giga Berlin, the build-out of Giga Berlin started slowing to a crawl. So we don't know when that cell production equipment will be installed, but let's assume it's by the end of the year. That means that Tesla could have about 200 gigawatt hours of installed equipment by the end of the year. At Austin, they're expecting to hit volume production, and at Berlin, I imagine they'll just be beginning the cell ramp by the end of the year. So if we're very lucky, and I'd say it's about a 50-50 chance, Tesla might hit 100 gigawatt hours of burst rate production by the end of the year for their battery cell lines. I don't think that would be 100 gigawatt hours of steady state production, because that's about 1 million vehicles worth of cells. So in order for Tesla to be able to use that many cells, they would have to have vehicle lines capable of producing another 1 million vehicles by the end of the year. Number 4, more cathode chemistries are being explored. Drew didn't specify which cathode chemistries he's referring to, but it's good to know that they're working around the edges to find different chemistry solutions to maximize the number of battery cells they can produce. Options include LFMP, which is lithium iron manganese phosphate, LMNO, which is lithium manganese nickel oxide, nickel manganese, which is 70% nickel and 30% manganese, or potentially sodium ion. Sodium ion seems less likely to me. I don't think we're going to see that in volume production until the mid-2020s. And when it does go into volume production, I expect it to be for energy storage rather than vehicles. Number 5, raw material supply looks solid for the next year or two based on the comments we heard from Elon and Drew at this earnings call. Now, deeper into the future, it will become increasingly difficult for Tesla to get the raw materials they need. However, the comments that Drew and Elon made at this earnings call also indicated that they're going to do whatever it takes to increase their raw material supply, and that the more difficult things get for raw material supply, the greater intervention we can expect by Tesla. So that's all for the day. Thanks for tuning in. I hope this video was of value for you. And as always, the links for support are in the description. The next video I'll be doing will be on Tesla's raw material strategy, and I expect that to come out within the next couple of weeks. Thanks for tuning in.